Most people search for a Claude code cheat sheet expecting a static document they can download and print out. They imagine a list of commands or a quick reference guide similar to what you might find for a Linux terminal or a complex software framework. The reality is far more nuanced and, frankly, more powerful. There is no official standalone document titled Claude Code Cheat Sheet. Instead, the concept refers to a specific adaptive framework known as the dynamic cheat sheet. This is a test-time learning method that equips large language models with persistent, adaptive memory. It allows the model to store and reuse strategies, code snippets, and problem-solving insights across interactions, rather than processing every query in isolation. Here is the thing. Generic tutorials focus heavily on prompt engineering. They teach you how to write a long, detailed instruction for the AI. But in a production environment, that approach often fails. The most effective Claude code workflows rely on iterative test-time learning. This means the agent refines its approach based on immediate feedback loops rather than relying on static prompts. Research indicates substantial performance gains with this method. Accuracy on advanced math exams more than doubled, and arithmetic tasks achieved near-perfect accuracy by recalling validated code. The system is self-curated to remain concise, avoiding context overload without requiring fine-tuning or human feedback. Now consider the challenge of context window management for large codebases. This is where the standard advice falls short. When dealing with a massive project, you cannot simply dump the entire codebase into the model. It creates noise. The cheat sheet functionality here focuses on context injection. Providing the agent with specific file structures and error logs is significantly more critical than the prompt's verbosity for achieving production-ready code. Think of it like giving a mechanic the car manual and a diagnostic report versus just telling them the car is making a noise. The mechanic needs the specific location of the problem and the system architecture to fix it correctly. This brings us to error recovery patterns. Hallucinations are a known risk when working with autonomous agents. The dynamic cheat sheet framework addresses this by emphasizing simple, atomic operations. The highest value commands are not the complex ones that try to do everything at once. They are the small, atomic operations that allow the agent to self-correct and verify its own output before finalizing code. If the agent makes a mistake, it does not just try again blindly. It stores the error as a lesson. This is part of the adaptive memory mechanism. It recalls validated code from previous interactions to avoid repeating the same failure. This self-curation ensures the system remains efficient and accurate over time. Let's talk about how this fits into a real development workflow. The evolution from version 1.0 to version 2.0 introduces a shift towards autonomous agent behaviors. The focus moves from specific command syntax to high-level goal decomposition. This is where continuous integration and continuous deployment strategies come into play. You cannot rely on the AI to write code in a vacuum. You need automated validation. The cheat sheet for production integration involves setting up a pipeline where the agent submits code to a test suite. If the tests fail, the error logs are fed back into the context. This closes the loop. The agent learns from the failure and adjusts its next attempt based on the actual system response rather than a hypothetical one. There is also a community-driven aspect to this methodology. Repositories established by developers like Njinga and Florian Bruno have standardized syntax for complex multi-step coding tasks. This standardization significantly reduces hallucination errors. When you use a consistent structure for defining tasks, the model can recognize patterns more effectively. It treats the task definition as a structured input that triggers specific internal reasoning processes. This reduces the cognitive load on the model and directs its attention to the relevant parts of the codebase. It is a way of forcing the AI to think in a structured manner, much like a human developer would when breaking down a complex feature. However, it is important to understand the limitations. While Claude's coding capabilities are enhanced by this framework, it is not traditionally classified as a dedicated coding assistant in general tool comparisons. Tools like GitHub Copilot operate differently, often focusing on inline suggestions. The dynamic cheat sheet approach is more about an autonomous agent that manages the workflow. This distinction matters when you are planning your development strategy. You are not just adding a coding assistant. You are integrating a learning system that gets better the more you use it. The primary knowledge gap remains the lack of a standardized, user-facing cheat sheet. The functionality exists as an internal algorithmic mechanism rather than a static reference guide. This means you have to build your own cheat sheet by understanding how the system learns. You need to document your own successful patterns. When you solve a difficult bug, the way you frame that solution for the AI is part of your personal cheat sheet. You are teaching the agent how to think about your specific code base. This creates a feedback loop where the agent becomes increasingly specialized in your environment. So what should you take away from this? The highest value commands are the simple atomic operations that allow the agent to self-correct. Do not try to write a prompt that does everything. Write a prompt that sets up a verification loop. Use context injection to provide the necessary file structures and error logs. Treat the interaction as a conversation where the agent learns from every failure. This is the production-hardened approach. It moves beyond the hype of a magic prompt and into the reality of building reliable software systems with AI assistance. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.